In this video, we are going to derive the synthesis equation of Dtfs. That means how can we express a periodic discrete time signal as a linear combination of harmonically related complex exponentials. We will also learn what is the meaning of magnitude spectrum, phase spectrum and frequency spectrum of a signal in this video.
The basic idea of discrete time Fourier series or Dtfs is that any periodic signal can be expressed as a linear combination of harmonically related complex exponentials. That is, any discrete time periodic signal x of n can be expressed as a linear combination of harmonically related complex exponential signals. For example, let us mathematically represent that as x of n is equal to summation k ak into phi k of n, which can be also written as summation k ak e power j k omega 0 n, which can be also represented as summation k ak e power j k 2 pi by n n, where the sequences or signals phi k n are the distinct harmonically related complex exponentials. And it is to be noted that these phi k of n are distinct only over a range of n successive values of k, and the summation in the above equation need only include terms over this particular range. Thus, the summation is with respect to k, and k varies over a range of n successive integers beginning with any value of k. It is not necessary that the k has to start from 0. We can start k in any values, but from k we have to take n successive values for the summation. So we can indicate this by expressing limit of summation k as angle bracket n. That is, x of n is equal to summation k in the range of n ak phi k, which is again equal to summation k in the range n ak into e power j k omega 0 n. Thus k can take any values, like for example k is equal to 0, 1, 2 up to n minus 1. So this many n distinct values. So then we will get n distinct harmonically related complex exponentials. It is not necessary that k has to start 0. You can take k is equal to 3, 4, 5 etc. up to n plus 2. Again, these are n distinct harmonically related complex exponential. Even you can take k is equal to 11, 12, 13 up to n plus 12. Again, we are not starting k at 0. We can start k at any values, but you have to take n distinct values. So in the above equation, the frequencies of the harmonics are given by 0, omega 0, 2 omega 0 up to n minus 1 omega 0 for k is equal to 0, 1, 2 up to n minus 1. Similar for other cases. And the fundamental frequency is given as omega 0 is equal to 2 pi by n. And this particular equation, that is x of n is equal to summation where k is within the range n ak phi k of n, is known as the discrete time Fourier series equation or the synthesis equation of Dtfs. Here the coefficients ak are known as the Dtfs coefficients, and we need to note that the Dtfs coefficient ak says the amount of each harmonic present in the original periodic signal x of n. Please note that we are trying to express the signal x of n as a linear combination of harmonically related complex exponential, and the ak, the coefficient ak, is the weighting function for this harmonically related complex exponential. How much a particular harmonic is present in the periodic signal x of n. That is the importance of this Dtfs coefficient. We can plot the value of ak as a function of k or a function of omega, and such plots are known as the Fourier spectrum of x of n. In general, this coefficient ak is a complex number, and we know that any complex number ak can be represented in polar form as ak is equal to magnitude of ak into e power j angle theta or j angle ak. And the plot of magnitude ak with respect to omega is known as a magnitude spectrum, and the plot of angle ak versus omega with respect to omega is known as the phase spectrum of the particular signal x of n, and these two plots together is known as the frequency spectrum of the periodic signal x of n. The Fourier spectra is an alternative way of describing a periodic signal x of n, and that is known as a frequency domain representation of the signal. And the actual signal x of n plotted as a sample values as a function of time index n is known as the time domain representation of the signal x of n. So that is what the basic idea of discrete time Fourier series.
I hope you got a clear idea about Dtfs synthesis equation, magnitude spectrum, phase spectrum and frequency spectrum.